Welcome to section 7.3, Addition and Subtraction of Rational Expressions with a Common Denominator and Finding the Least Common Denominator. Two fundamental ideas in adding and subtracting fractions are the two following formulas. When we add fractions a over b plus c over d, we cross-multiply and add in the numerator so that we have a times d plus b times c. Then we multiply denominators, b times d. When we are subtracting fractions, we do the same operation. We cross-multiply, but now we subtract in the numerator, so that it becomes ad minus bc all over b times d. When we are adding and subtracting fractions that have the same denominator, we can apply a shortcut, and the shortcut is simply to add or subtract numerators and keep the denominators the same. For example, if we wanted to add 4/7 and 2/7, because the denominators are both 7, we can simply add the numerators. So that we add 4 plus 2, we get 6 in the numerator, and we keep the denominator the same. If we were to add using the previous formulas, we get the same answer, but it takes a couple more steps. We cross-multiply so that we have 4 times 7 plus, we cross-multiply 7 times 2 all over 7 times 7. In the numerator, this gives us 28 plus 14. In the denominator, we have 49. As an answer, we have 42 over 49. But the 42/49 can be simplified. We have an extra factor of 7 in the numerator and denominator. Canceling the extra factor of 7 gives us a final simplified answer of 6/7. The same principle holds when we are adding rational expressions. When the denominator is the same, we can simply add the numerators and keep the denominators the same. In this case, we have x over x minus 3 plus 4x plus 9 over x minus 3. The denominators are the same, so we are allowed to take the shortcut. We add the numerators, x plus 4x plus 9. Combining like terms, this gives us 5x plus 9 in the numerator, all over x minus 3 in the denominator. Sometimes, once we have done the operation of addition or subtraction, we still need to simplify the expression. For example, suppose we are asked to subtract 4x squared plus 15 over 9x squared minus 64 minus x squared minus x plus 39 over 9x squared minus 64. Again, the denominators are the same, so we are allowed to just subtract the numerators. We have in the numerator 4x squared plus 15 minus the quantity x squared minus x plus 39. Distributing the negative, we have 4x squared plus 15 minus x squared plus x minus 39. Combining like terms, the x squared, 4x squared minus x squared gives us 3x squared plus x, and then minus 24. All of this over 9x squared minus 64. Once we perform the subtraction, we need to simplify the expression. We factor the 3x squared plus x minus 24 into x plus 3 times 3x minus 8. Our 9x squared minus 64 is the difference of squares, so it will factor as 3x plus 8 times 3x minus 8. Canceling common terms of 3x minus 8, we are left with a final answer of x plus 3 over 3x plus 8. When we are looking for the least common denominator, we are finding the smallest polynomial which is divisible by each of the other denominators. To do this, we must factor all the denominators into primes, and then we take the largest power of each prime which appears in a factorization. For example, coming back to concrete numbers, if we have the fraction 1/42 plus 1/48, we factor the denominators into primes. 42 factors as 2 times 3 times 7. 48 will factor as 2 to the 4th times 3. Our least common denominator then has a factorization of 2 to the 4th, that's the highest power on the 2 that we have in either factorization. We have a 3, which again is the highest power that we have on either factorization, and 7, which again is the highest power that we have on the 7 in either factorization. Our least common denominator is then 2 to the 4th times 3 times 7, which gives us 336. The same principle applies when we are looking for the least common denominator of rational expressions. Here we have denominators x squared plus x and a denominator of x. Factoring the denominators, we have x squared plus x equal to x times x plus 1, and x is only x. Therefore, we have the primes x and x plus 1. Our least common denominator, the largest power of either of both primes, is 1. We have x to the first power, x to the first power, x plus 1 to the first power. So our least common denominator will be x times x plus 1, giving us x squared plus x. In our next example, we have denominators 2x squared plus 5x plus 2 and 3x squared plus 4x minus 4. Factoring the denominators gives us 2x squared plus 5x plus 2 is equal to x plus 2 times 2x plus 1. 3x squared plus 4x minus 4 factors as x plus 2 times 3x minus 2. The primes which appear are x plus 2, 2x plus 1, and 3x minus 2. Once again, the largest power of each prime which appears in any factorization is 1. X plus 2 to the first power, x plus 2 to the first power, 2x plus 1 to the first power, 3x minus 2 to the first power. Therefore, our least common denominator will be x plus 2 to the first power times 2x plus 1 to the first power times 3x minus 2 to the first power. Expanded out, this gives us 6x cubed plus 11x squared minus 4x minus 4.